Hi, I'm Kathy Levinger. In this section, we're going to practice using properties of exponents. Here are the rules that you'll find in your book. For real numbers, a, b, m, and n, these 7 properties are listed. And let me describe them in words and then we'll work some examples. The first property shows a to the m times a to the n. When you multiply terms where the bases are the same, to multiply them, add the exponents and attach that sum to the base. The second rule says if you have a base with an exponent and you raise that to a power, what you do is multiply the powers. The third rule says if you have a product to a power, you can take that power and attach it to each factor in the product, or ab to the m is a to the m times b to the m. The fourth rule explains what to do with a negative exponent. If you have a base to the negative n power, that can be written as 1 over that base a to the n power, which is the same as or equal to the fraction or reciprocal of a, 1 over a, to the positive n. So you could skip the middle step and say a to the negative n is the reciprocal of a to the positive n. The fifth rule says if you're dividing and the bases are the same, what you do is subtract the exponents. The sixth rule says any real number except 0 to the 0 power is equal to 1, and so we should make the exception here that a itself cannot be 0. And our seventh rule is that if you have a fraction to a power, that power can be attached to each part of the fraction, the numerator and the denominator, provided, of course, that b to the n is not 0 and b itself is not 0. Well, let's try out some of these with some examples. Here we want to simplify using properties of exponents, and we're going to write our answers with positive exponents only. Our first example reads x to the 5th times x to the negative 2 times x to the 3rd. This is a product of 3 terms all with the same base. When we multiply them, we take that base to the sum of the powers, 5 plus negative 2 plus 3. 5 plus negative 2 is 3, plus another 3 is 6, and so the end result is x to the 6th. Our next example gives us 5t squared, all of that to the negative 3 power. Well, when we have a product, 5 times t squared, to a power, the power is attached to each part of the product. And so I've taken negative 3 and attached it to 5 as an exponent, and negative 3 is an exponent on t squared. Now simplifying each part, 5 to the negative 3 means 1 over 5 to the positive 3. As a first step in simplifying t squared to the negative 3, when I have a power to a power, I multiply exponents, and so I'm going to get t to the negative 6. Continuing, I know 5 to the 3rd is 125, so I'm going to write this fraction as 1 over 125. T to the negative 6th is written 1 over t to the positive 6. And finishing the multiplication here, it's a multiplication of fractions. Multiply the numerators, multiply the denominators to get 1 over 125 t to the 6th power. Well, here's our final example on this page. It's p to the negative 1 q to the 0, all of that to the 3rd, times p to the 3rd q to the 5th, all of that squared. Starting with the first bit in parentheses, attach the 3rd power to each item, to each factor inside, to get p to the negative 1 to the 3rd times q to the 0 to the 3rd. Doing the same thing for the second set of parentheses, I have p to the 3rd squared times q to the 5th squared. Now, simplifying further, each time I have a power to a power, I multiply the powers. So I have p to the negative 3 times q to the 0 times p to the 6th times q to the 10th. Now, q to the 0 I know is 1, so I'm going to simplify that to 1, and that will leave me with p to the negative 3 times p to the 6th times q to the 10th. The final step is to multiply p to the negative 3 times p to the 6th by adding the exponents. Negative 3 plus 6 is 3, so this becomes p to the 3rd, q to the 10th. Well, let's try some more examples. Here we want to simplify using properties of exponents, and we want to write our answers with positive exponents only. And the first example reads x squared y to the 4th over x to the 5th y squared. In this case, we need to use the properties that involve dividing like bases. Dividing the bases that are x's, I'll subtract the exponents and I'll get x to the 2 minus 5 power. I multiply that by the y's divided in the same way, subtracting exponents, y to the 4 minus 2 power. Simplifying those subtractions, I have x to the negative 3 y squared. I need to write my answer with positive exponents, so this x to the negative 3 must be considered 1 over x cubed. Now this is a multiplication of fractions. Y squared is y squared over 1, and so I'll multiply y squared times the 1 in the numerator and x cubed times the 1 in the denominator to get y squared over x cubed. Our next example reads 3r to the negative 3t over 9r to the negative 3t to the 5th. Again, we'll simplify numerator to denominator. 3 over 9 simplifies to 1/3. R to the negative 3 divided by r to the negative 3 simplifies to 1. Anything over itself is 1. And to find t divided by t to the 5th using properties of exponents, I find that as t to the 1 minus 5 power. T by itself is t to the 1st power. Simplifying further, this is 1/3 times t to the negative 4th, which is 1/3 times 1 over t to the 4th, which if I multiply numerators and multiply denominators is 1 over 3t to the 4th power. Finally, I have the fraction in parentheses 4 over d to the 4th, all of that to the negative 2. As a first step here, I'm going to take the negative 2 power and attach it to the numerator as an exponent and the denominator as an exponent. Simplifying the denominator on the next step, I'll keep my 4 to the negative 2 for a moment. I have d to the 4th to the negative 2, which is d to the negative 8, found by multiplying the exponents. Now, each term, the one in the numerator as well as the one in the denominator, has a negative exponent. The 4 to the negative 2 becomes 1 over 4 squared. The d to the negative 8 becomes d to the 8th over 1, or I can move them in their fractions, in the fraction, using the reciprocal rule. As a final step here, I need to find 4 squared, which is 16. And so the final answer is d to the 8th over 16. Let's look at one more example involving exponents. What we want to do here is simplify using a calculator, and then we're going to check by hand. So this is a good way to practice entering expressions with exponents in your calculator. Our first problem is 10 to the negative 5th times 10 to the 8th. So on the calculator, enter exactly what you see in the problem, 10, using the exponent key, which is underneath the clear button and gives you a little caret on your screen. 10 to the negative 5th power times 10 to the 8th power, and we get the number 1,000. Now you may know that 1,000 is 10 to the 3rd, so let's write 1,000 down and then check using properties of exponents. To use properties of exponents to multiply these, the base is 10, and we would add the exponents, and negative 5 plus 8 is 3, and 10 to the 1/3 is 1,000, and that checks what we got when we worked it on a calculator. Well, let's do that for the next problem. The next problem reads 4 squared times 5 to the negative 3, all of that to the 0 power, times 4 to the negative 2 times 5. Well, let's enter that on a calculator. We're going to enter 4 to the 2nd times 5 to the negative 3rd, all of that to the 0 power, times, parentheses, 4 to the negative 2 times 5, close parentheses. Now the answer we get on the calculator is 0.3125. Well, let's write that down and then work the problem by hand and see how that confirms what we just did. So we're going to write our 0.3125 down and then work the problem by hand. Now this whole first term is something to the 0 power, so the whole first term is going to simplify to 1. 4 to the negative 2 is 1 over 4 squared times 5, which I'm going to consider 5 over 1. Multiplying the numerators here, I get 5 over 4 squared times 1, which is 16. Well, is 5/16 0.3125? If you grab your calculator and do 5 divided by 16, you'll find that it is exactly 0.3125. And that confirms what we got with our calculator. Well, in this lesson we've practiced a little bit with exponents. Be sure to work some problems from your book and get more practice.